anybody can write in any language. You have like this kind of instant translator. If you're a starting engineer, show what you're building. Like, don't tell people, show them. With generative AI, it's really easy to make a demo, and it's really hard to make a product.
This is the Future of the Future show. I am your host, Mateo Berbejicio. AI is at an inflection point. Everyone is talking about it, but very few are turning it into real, measurable business value. Why do some companies break through while others stay stuck in experimentation? As agents and orchestration redefine how software is built, what does this shift actually mean for engineers on the ground? To unpack this, I am joined by Alon Bochman, someone who's been working in AI long before the current hype cycle. Alon is a fractional AI executive who helps enterprises and startups turn AI from buzzword into business value. He's led AI transformations that saved tens of millions and unlocked new revenue streams, including scaling an AI consulting practice to over 1 billion in just 4 years and growing portfolios from thousands to tens of millions annually. He's co-founded and exited a startup to Thomson Reuters, helped GenAI companies secure funding, and worked hands-on as a CTO-for-hire. With that mix of deep history and hands-on execution, Alon is the perfect person to explore what's actually changed in AI, why some companies win, how engineering is evolving, and what bets are worth making right now. Alon, thank you so much for being here.
Thank you, Mateo. I'm really excited to talk to you about this.
Alon, take us back in time. How did you get into AI over 20 years ago?
Sure. Right after business school, I joined a boutique consulting company that was in two lines of business. One of them was management consulting. That was the line that I was recruited for. And the other one was what was then called data mining. And it turned out that even though I was recruited for one of the businesses, the other one was a lot more interesting to me. And also, this company was much further ahead in the other one than in the first one. And so I quickly went through the training that was available and caught the bug and have been doing, things with data and numbers ever since. So that was my start. The company was in kind of a unique position of doing data science, doing management consulting that's kind of bottom up. So instead of starting with the market and with the big trends and looking into the big crystal ball and figuring out the big important things, they started with the little things, kind of the trace of data that happens out of every business. And the biggest client that we were serving at the time was American Express. And I had the privilege to help American Express roll out a couple of really highly predictive models around predicting who's going to pay back their loan, predicting who's going to be the highest value customer that should get the most valuable customer service, and many things along those lines. And this was back in the early 2000s. We were basically, replacing statistical technology from the 1960s with
Wow.
slightly newer statistical technology from the late 1990s. And this upgrade fit the data much better and was a lot more predictive. And so American Express made, hundreds of millions of dollars from that upgrade just by being able to see the future with a bit more clarity. And this was so exciting to me that you could make such a small change and have such a big impact. And you could trace it like down to the individual customer and down to the individual decision. And I kind of got hooked on this, and I did my best to build a career from that.
What do you think has changed the most since those early days?
Well, we're living in a completely different technological age. So the experience that I just described to you has to do with building machine learning models, data science. So this is dealing with um, structured data inputs and structured data outputs. So that's basically numbers in and numbers out. So the numbers in might be things like the annual income of the person that's making the phone call, and also how much credit they're asking for, and whether they're married or not, and whether they've worked for the same employer for a year or longer or less, how many months. So it's all numbers. It's a
Yeah.
lot of questions and numbers. And from these numbers, you can basically figure out, you know, take these numbers alongside with the final outcomes that you're trying to predict, like who paid back their credit card and who didn't, or who charged a lot of money and made American Express a lot of money and who didn't. And then you can identify patterns. Automatically, you can identify patterns. So instead of using judgment, you can kind of let the computer find the patterns, but it's still dealing with numbers in and numbers out. And now we're in this really exciting time when we're not limited to numbers in and numbers out. We type our prompts into the chatbot, and the chatbot types their thoughts back to us. So we're dealing with text in and text out, images in, images out, audio, video, and lots of other modalities. And that means that the computer is no longer stuck sort of in this box in the basement dealing with the bowels of American Express. It's kind of like everywhere.
Right.
It's helping us make day-to-day decisions. And also when it comes to using it inside a company, there's a million other ways to use it.
Um, why do you think some companies are achieving real business results from AI while others are not?
It's a really good question. The answer is complicated. There's a lot of reasons. Maybe the easiest reason is that with generative AI, it's really easy to make a demo, and it's really hard to make a product.
Right.
And the difference between a demo and a product is in a demo, you are controlling the scenario. You control what the demo scenario is, what happens during the demo. You're like the movie director, and the people in the demo are kind of like your cast. You tell them exactly what to say and do, in what sequence, when is going to be the new screen. Everything happens the way you say. But when it's an application, there's real users. When you get to real human beings, they say all kinds of things that we never imagined they would say, and they do all kinds of things that we never imagined they would do. And this is the joy and beauty of life, right? Um, but unfortunately, it makes it that much harder to build an application. You have to start planning for the infinite variety that is, human users, and it's much harder. So first of all, it's harder in that it takes a lot more planning. It's also harder because it takes different kinds of thinking. Humans will use your application in a way that you never imagined. It also takes somewhat different skill sets than sort of traditional software building, and a lot of organizations don't have those in-house, or maybe they would like to have those, but hiring for those takes some time and takes money. Those skills are in demand today.
What are some of those skills?
Well, you could start with the maybe the most famous of those skills is prompt engineering, right? Lots of people
Yep.
have heard of
Yep.
prompt engineering. So what is prompt engineering? Like, why don't we just call them writers? We call them prompt engineers because you are essentially programming this large language model in English.
Yeah.
So it's not quite like being a writer. When you're a writer, you have, all of the English language to use, and you're judged based on maybe the point that you get across to people or the emotional impact that your writing has, or whether it's logical. So there's lots of different ways to judge writing. But when you're a prompt engineer, you are an engineer. You're engineering an outcome. Your
Yeah.
your medium is English, your language, maybe Spanish, but like you're engineering an outcome. You're adjusting your input to get exactly the result that you want back. And just like in any other engineering process, there's a lot of trial and error. There's a lot of exceptions that you have to plan for, and it's usually not going to come out the first time. So, you're going to have to rewrite many times and try it and keep getting kind of the imperfect answers and keep going. So that's like the most famous skill. But there's lots of other skills. There's skills around evaluation. There's skills around architecting an AI system that's a little bit different than architecting a traditional software system. There is, AI systems can sometimes scale much bigger than traditional systems have. So there's a mix of things we can go into it, but um, at least for the moment, a lot of these skills are there's places where you could learn them, but it takes time, and
Yep.
the demand is just ahead of supply at the moment.
Yeah. So engineering is really changing, right? With agents and orchestration, and it feels like we are evolving towards that sort of architect, right? The I don't know what you think, Alan, but the front end engineer that just had a small degree online and used to be able to demand high salaries in the past, or it doesn't seem to be there anymore, or not as much in demand, right? But what you were just describing, someone that knows prompt engineering, that knows how to evaluate, that knows how to do architecting, is very up in the mind, right? So um, talk about that. Talk about how is engineering changing with everything that's happening right now, and what is how do you think about the software engineer today?
I think that almost every role in business today has scope to pick up AI skills, change what they do, up level, and become in demand. I don't think that it's limited to just reimagining engineering, but I'll start with engineering because that's where your question is. Um, I think that what AI changes is it takes away all the friction of memorizing. So, I used to avoid learning new programming languages because it's a pain in the neck and I already know how to say something in one language and, all I get in another language is like maybe I could say the same thing and maybe it's a little faster or maybe it's a little bit better for this one application, but it's a pain in the neck to learn a whole new language for that. I hate memorizing. I'm not good at it. I have the opposite of a photographic memory. And so it was always a big effort for me. And every time that I would learn a new language, I'd have to pick up the textbook and go through the examples and like line by line and figure out like every character. Like I'd make all the mistakes and leave off the semicolon and, capitalize the letter when I shouldn't have and the variable doesn't match. I made like all these mistakes hundreds of times. It's a
Yeah.
huge pain in the neck and it's all gone. Like it's all gone. It's all obsolete. It's like it's like writing on parchment with with a quill pen. It's just gone. It's in the past. So you take away all of that friction, and basically what it means is anybody can write in any language. You have like this kind of instant translator. You're capable. Like you want to write in assembly, you can write in assembly. You don't have to know assembly. You want to write in Rust, you want to write in Python, you want .NET, whatever, COBOL, you could do it. So what does that leave? So the skill of knowing the language and understanding the memorizing and understanding the library, like that's not the valued skill anymore. So what's left? Well, you still need to you still need to figure out what's the right problem to solve. You still need to architect the system correctly to solve it. You still need to adjust and be flexible to what your users and team is asking you to do, what your customers are asking you to do. So you can't be rigid. Um, and now that you have these tools that are removing all these frictions, you have a lot more deadlines. Like people expect stuff faster. So that's the nature, right? Like when we got the train, people no longer wanted to wait for like 2 weeks for you to get from city A to city B. Now you're supposed to get there in a couple hours, right?
Yeah.
Everybody adjusts their expectations. And same thing with engineering. So I think that most engineers are going to become full stack engineers, not just back end, front end, middle, but like all the languages, all the platforms, every type of computer from the Raspberry Pi up to the, NVIDIA cluster. Like it's all available. You still have like a lot of skill involved in designing new algorithms, architecting a system, and sort of matching, making the right trade-offs to get what the customer needs quickly and cheaply. Um, And I think that something similar is happening in other roles. Like if you think about non-technical roles, think about a product manager. I see, teams where product managers are expanding into engineering. It doesn't mean that they especially want to code, but it means that they can get their ideas across
Yep.
more vividly by just showing you what they have in mind with a prototype instead of writing about it in a spec.
Yep.
So it turns out that when you're creating a prototype, you have to make lots and lots of choices, and those choices explain how you're thinking in a better way than, a super detailed PRD does, in a more comprehensive way. So I see a lot of teams getting smaller, just like fewer people. They're usually better paid people. They usually have tighter deadlines. And the roles I see are like the roles are more overlapping. So, you have a full stack engineer that also has opinions about like what features to develop. You have a product manager that is able to build prototypes. You have a designer that's also like able to build some backend code. So they're kind of merging. Um, and and I think that AI is used in like lots of places way beyond engineering too. So it's like it's used in thinking through the alternatives. It's in critiquing your thinking, so that you can have a kind of a devil's advocate.
Yep.
You can up level yourself that way. So yeah, I think of it as being pretty broad.
So how do engineers get ready and adapt to these changes, right? Because not so long ago, I remember, engineers that will be like, just send me the user story. I just want to focus on coding, right? And you were saying
Right.
the days of actually doing the coding and remembering and memorization of how to write it are gone. You are now more of a full stack architect. You are understanding the problem, architecting the solution, talking to the customer all the time and adjusting and having that ability to adjust. Um, and you're doing things faster. How do they
Yeah.
get there? If someone is listening and they go like, "Oh, but how do I
It's a
do that?"
great question. It's a great question. So this is what I would literally do if I were just starting out. And by the way, Matteo, I should admit that I've never taken a computer science class in my life. So whatever I learned, I like taught myself from like books. It was really hard and slow, maybe inefficient, maybe incomplete, but that's just me. So I just want to admit my limitations before I start giving some advice. Um, if I were a junior engineer, maybe a college student studying software, maybe just in the workforce, the first thing that I would do is I would start building stuff. I would probably look for some open source projects that are in the space that I'm interested in. Maybe they are AI first projects like OpenClaw or other, there's a bunch of high profile AI projects that are looking for contributors. Maybe they are applying AI to a domain that I'm interested in. Like maybe I'm into hotel management, so there's
Mm.
probably AI for hotel management. Maybe I'm into agriculture, whatever it is, right? There's plenty of stuff to build. I wouldn't worry about the money. I would just join a group like GitHub has like plenty of projects that are asking for people. I would join an active community where there's going to be a nice mix of junior, mid-level, and senior people, especially if somebody is willing to spend a little bit of time with me to show me like what needs to be built. And I would just give it a shot. They're not going to hold my hand. And probably the first pull request that I create is going to be terrible. Maybe the fifth and tenth one is also going to be terrible. But I'm going to get feedback and quickly I'm going to improve. And if I do have some code accepted, that's my that's my proof. That's the best proof. That's better proof than whatever school I went to or whatever degree I have, whatever brand I have on my resume. I could show that I shipped feature X in a week, 2 weeks, 3 weeks. That's where I would start.
Hands-on experience beats everything else.
For sure. I had this problem in data science. So at one point, I was working for a big a big consulting company. It was very large. It had maybe like 100,000 people around the world. And this company hired a bunch of people like me to improve their data science capability. But it also had a very aggressive capitalist kind of mindset inside the company. So there was a lot of internal competition.
Yep.
And the idea was that, listen, this is not a communist, this is not a communist country. If you want business, you got to go and get the business. And if you're going to have to compete, and the business is not going to come to you, you're going to have to go and get it. And this was like they're very proud of this. But in practice, it meant that like the only way that you could get to speak in a meeting is if you shout over everybody else.
Right.
And this was not my style. I was very bad at this. So, like when somebody else started talking in the meeting, I would just wait for them to finish, and they never finished. Like there's a wall of sound. So I never, it's not like you're actually giving me a chance to say something, but it was not like this at this company. And so for a while there, like I had a lot of trouble, just getting any kind of attention from customers. And I was thinking like, gee, like how can I think I know some things about data science, but how can I prove it to people without just like yelling over everybody? What can I do? And so what I did was, this is not the only way, this is just what worked for me. I joined a global data science competition website. It's called Kaggle. It's owned by Google. It's, arguably the largest data science competition platform in the world. There's something like, I don't know, 50,000 competitors every year. There's 500,000 members. And the competitions are graded by computer. So it's completely objective. It doesn't matter if you're rich or poor, well connected or not, like the best model wins. And I was very fortunate. I connected with some people who are way smarter than me. We won a couple of competitions there, and I got a couple of medals. And after that, like I didn't have to say much. I would just like kind of like hold up the medal, and then the clients started finding me. I didn't have to be super loud. So this is kind of a long story, but the point is that if you're a starting engineer, show what you're building. Like don't tell people, show them.
I absolutely love that advice. Let me go back to when we were talking about companies using AI, and you were talking about the difference between a demo and a product, right?
Yeah.
And I gather there's a lot of expectations from your customers when you're consulting with them. So, in your consulting work today, what does actually delivering AI value look like?
Do you mean which use cases, or do you mean an example of a journey from demo to production?
More like how do you define value and how you communicate that with the clients and how, because I also imagine that, and I see this in our line of work, I see that sometimes because doing a demo is so easy, right?
Mm,
Customers sometimes get confused about what's a demo and what's a product, right?
that's right.
And then they go like, "Oh, I was able to build this myself in like a month." Yes,
That's
but it
right.
breaks all the time, right? But
That's right.
so how does that work for you, and how do you um, work with your clients through that and to have a common definition of what AI
I got you.
value looks like?
Okay. So, okay. So there's two questions here. I'm going to focus on the second one. I think that's what you mean. First question is, when you talk to a customer, how do you figure out where to place your bets, like what to build, what's going
Yep.
to be the most productive? And the second question is, after you've started, you've gotten to the demo stage, how do you get on the same page with the customer about, like, is it 0%, 10% done, 80% done, 90% done? Like, how do you measure quality? So I'm going to focus on that second question. Um, I think that the single biggest tool to get you there, to get you to a visible and countable, quantifiable quality, is evaluations. So, an evaluation is basically a set of inputs and expected outputs that you would like to get from your chatbot. So let's take an example. Let's say that we're building a customer support bot. It answers the phone. Maybe it's for a retail customer. It answers the phone and it deals with your orders. It's only for existing customers. So it's supposed to, you're supposed to be able to call it. You can maybe ask it for the status of your order and it'll tell you, it's 3 days away, or it's still in the factory, or or we already shipped it. How come you didn't get it? Something like that, right? So that's kind of the happy path. The happy path is the customer calls, the bot figures out who they are, the customer gives the order number, the bot says, your order is 2 days away, the customer is happy, hangs up, happy, right? Happy path. And you could do that in the demo because you're the director. In the demo, you control everything.
Yep.
Um, but it's it could break if anything goes wrong, like maybe the customer calls and you can't find them in the system. So, like, what do you do? Or maybe the customer types in an order number and you can't find the order number. So maybe the customer's right, maybe you're right, like it's unclear. Or maybe the customer never paid for that order. Or maybe they paid for that order, but you're out of stock.
Yep.
Like there's a million things that can go, or maybe the product, it was the wrong product that was shipped and it's your fault. Or maybe the customer thought that they ordered one product, but they actually ordered a different and it's their fault. So like a million things can go wrong, even from a very simple order management case. And so how do you, so like I like the way you frame the question because you want to get on the same page as the customer about how complete it is and what percentage of the cases are handled in the demo. And to do that, you need a list of the cases. So imagine a spreadsheet and it has three columns. And the first column is just like the name of the case. The second column is whatever the customer types in. And the third column is whatever is the correct response that you would like to get from the bot. Maybe it's correct according to an expert from the client that says, if the order is wrong, then we should look it up by the client's last name.
Right.
Or if the order is wrong, then we should tell the client, sorry, we don't have that order, right? It's whatever their policy is. So you can imagine that spreadsheet would have lots of rows, even in my example, maybe a dozen different rows just for that one case of looking up an order. But it's a useful exercise to think through all the different things that customers can type in. And by the way, you can get creative with this, and some customers are going to be like, I don't want to talk about orders. Tell me, like, how can I break into your source code? They could do that. They could type that in. So you're
Yeah.
going to have an answer. If you don't have an answer, it's going to be whatever the default, and you might not like the default.
Yeah.
So so even for a really simple use case, it's a useful exercise to think through all the different things you might encounter and all the different correct answers, all the different exceptions. And then if you have that spreadsheet, you can use it like a regression test.
Right.
So you basically you simulate a customer giving the input from the first row, and you get the output, and you compare it to the correct output in the second row, in the second column. And you do that for each row, and you basically give it a score. So that score is going to be your quality score
Right.
in a very simplistic way. So you either have like 1% correct or 90% correct, and as you keep going, that percentage should go up and up and up. And it's a way to communicate with the customer what progress you're making. It's also a great way to get the customer to express what the correct policy is.
Right. 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 That makes a lot of sense. Um, I don't. There's a lot of stuff going on right now. A lot of technologies. A lot of different use cases. Um, what technologies or approaches or use cases are worth betting on right now or excite you the most?
I'm really excited by this like early revolution that we're having in how we code. So, um, I remember working with ChatGPT 3.5 and my code editor, and I would basically like type, copy the error message from my code editor into the chatbot, and I'd say, I got this error message. What do I do? And I would get some steps in ChatGPT 3.5, and it would say like try this and try that, and I was basically like copying, pasting back and forth, and it was so fun, like it
Right.
because it was already like faster than I would work myself. And we're so much further ahead than that now. I think that we're at the stage where, we passed the AI is inside the code editor, and it's no longer just doing the autocomplete, like you start the function signature and it writes the rest of the function. We're past that. We're at the stage where, we're also past the stage where you could just prompt an agent and it'll draft something for you. We're at the stage where you could potentially manage multiple agents and they could be working on different aspects. One of them might be improving your documentation. One of them might be improving your test harness. One of them might be refactoring your code. One of them might be thinking through your next feature. One of them might be making your marketing page or landing page or however you communicate with customers. Um, so all of these can work independently. And I think that the bottleneck is increasingly how quickly can you verify the work that the agents are doing.
Right.
So the challenge is basically to come up with systems where the agents can verify work themselves. If you can articulate the standard of what it means to succeed to the agent in an objective way, and you can give the agent a very, a clear way to say, if you do this, it's correct. If you do that, it's incorrect. Or like this is what I want, this is what I don't want. Then the agent can keep trying until they get what you want. And
Yep.
if you multiply that across, several agents that you're working with, you're getting more and more leverage for every sort of human decision or intervention. So I think that that kind of like leverage that you get, it's like how many minutes of agent time can you get for every minute of your attention?
Yep.
And you want, like the more agent time you can get for every minute of your attention, the more productive you can be. And nobody knows the upper limit yet. But
Yeah.
it could be like, it could be quite high. Like it might be 100 to 1, it might be 1,000 to 1. We don't know. But I think there's some art to figuring that out. I won't pretend that I know exactly how to do it. I have a couple of, I have a couple of ideas, but I'm experimenting every day, just like you, I'm sure.
Alon, thank you so much. This has been an amazing conversation. We could be keep going on and on. And I hope that we get to spend some time again in the future and talk about the evolution because probably in the next 6 months things will change again, right?
Yeah,
So
that's
if
right.
you're up to it, I will hold you and I will come back to you and do another episode.
It's my pleasure, Matteo.